So in this video we shall talk about Gauss's law for a very small volume, differential volume. That means it will be Gauss's law applied for a cuboid of sides dx, dy and dz respectively, and the center of the cuboid will be at x, y, z, and the electric field in space E that will be dependent on all the three coordinates. That means this electric field E is a function of x, y, z. X, y, z, all three. So that means E is equal to what? Ex times I cap plus Ey times j cap plus Ez times k cap. Okay. Now let's consider a cuboid. Consider a cuboid with center at, see, as I said, center at x, y, z, and sides as dx, dy and dz respectively. So let's draw this. This is the center x, y, z, and this sides will be parallel to the x, y and z axis. So this will be, so let's remove this x, y, z, right? So just remember that center of this cuboid is at x, y, z. Okay. So these sides, this side is dx, and so this side happens to be dy, and the vertical side happens to be dz. And the center, now I'll mark the center by this red dot. Center of this cuboid is having coordinates x, y, z. So let us look at the two faces of the cuboid, this face and the other face. The two faces, I am making this green shade. Now we are calculating the flux through those two green faces, right? So so the entering flux, sorry, just a minute. So here see, if you consider these green faces, that means the faces parallel to the yz plane, then Ey and Ez will have no role to play. Okay, the flux, that means the field lines which is crossing through these green surfaces, will be those parallel to the x-axis. So just add the midpoint of this green dot. The electric field happens to be, see, at the center point the field is exi plus eyz plus ezk. Okay, so E is equal to at point xyz. Now, so just to the the center of this left face, the field is ex minus del ex by del x times dx by 2. You understand this, because see, it is we have to consider variation of this field component ex with respect to the x-axis only, right? Because of these lines, if you see the line, so this line, this line is parallel to x-axis, and the y and z coordinates are so in no way they are changing, right? Consider this line, this blue line. Okay, so it is del ex by del x multiplied by dx by 2. Okay, Now let us look at the point, this black spot, that means the center of the right green shaded face. So there the electric field happens to be Ex plus, let's remove this dz, let's move this dz far. Okay, so here it is Ex plus del Ex by del x multiplied by dx by 2. So through these two green phases, what is the net flux out? Net flux through this green phases, through the green shaded faces, is equal to, just you have so that, yeah, that's the field. Now the flux, to calculate the flux, so the area of this green shaded faces is how much? What is the area of each such green face? So the area of each green face is equal to obviously dy times dz. Same about that, dy times dz. So the net flux through the green shaded faces is equal to flux out minus flux in. So this is del E by del Ex by del x times dx. If you subtract, so it's multiplied by dy into dz. Okay, you can try it, do it on your own, that multiply this field by dy into dz and multiply this field by dy into dz and subtract, because this one is flux out, this one is flux in. So after you subtract, you will get the value what I have got here. Okay, similarly, similarly there will be other shaded faces also. Let's draw the green, this red shaded faces, this one and the bottom one. That means the faces parallel to the xy plane, and also the blue shaded faces here. Okay, blue shaded faces, that means the faces parallel to the xz plane. Okay, by the way, what will be the net flux? Similarly, we know that what will be the net flux out of the cube? Net flux out of the cube, cuboid rather, cuboid, is equal to, similarly you can write this del, so dx dy dz common. Now it is del Ex by del x plus del Ey by del y plus del Ez by del z. Okay, I hope you are convinced with this, because see, just I am telling you that see, this is the net flux through the green shaded faces. What will be the net flux through the red shaded faces? See, through this upper face I am showing this, what is the field that will be parallel to z axis. So it's Ez plus del Ez by del z multiplied by dz by 2. Similarly, there will be this field through downward and this blue face also. However, you will get the net flux out of the cuboid. Okay, now suppose if rho is the charge per unit volume, right? If rho is the charge per unit volume of space, therefore we can now we will apply Gauss's law. Gauss's law, that means the net flux dx dy dz multiplied by del Ex by del x plus del Ey by del y plus del Ez by del z. Now that's equal to the charge enclosed by this cuboid. So charge by volume, charge density in space, rho multiplied by the volume of the cuboid is dx dy dz. So now this dx, dy, dz will cancel. Okay, I missed out this epsilon naught below. So yeah, so now it is. So if you have the components of the fields, so this is Gauss's law in one form: del Ex by del x plus del Ey by del y plus del Ez by del z is equal to rho by epsilon naught. So this is one form of Gauss's law. Okay. Now there, this is the differential or del operator. This is a way to express the things. This is the del operator. It comes with a vector sign. Del operator is del x times I cap plus del y times j cap plus del z times k cap. And so del operator dot e. What will be del operator dot e? This is known as divergence of a vector or divergence of e. Later on you will learn about vector calculus. That will be taught in the undergraduate course, but just a brief introduction I like to give you. So this is known as divergence of e. So this is just an operator. See, if you just look at it like simple dot product, so then only you get this del or this divergence of e. Divergence of vector e is same as del operator dot e. That is same as what I have written, del x, del Ex by del x plus del Ey by del y plus del Ez by del z is equal to rho by epsilon naught. So, or directly you can write this del dot e or divergence of e is rho by epsilon naught. So now you may need this to solve some problems.